Hi, this is Prem Kumar, Assistant Professor at Department of Computer Science, Tiritangal Nadar College.
Hi, this is Prem Kumar.
Today, I am going to give you a session about the data science. The data science is a scientific study of data to gain a knowledge and make informed decisions. It is a disciplinary field that combines the principles and the practices from many areas, includes mathematics, statistics, business, artificial intelligence, and the computer engineering. The data scientists uses the tools like the data analysis, machine learning, and the artificial intelligence to analyze the large amount of data and extracts the insights. They ask and answer the questions like what happened, why it's happened, and what can be done with the results. The insights they gain can help businesses make decisions, improve the customer satisfactions, and develop the new products. The data scientist, that is the data science, is the a fast growing field with many job opportunities, including a data scientist, data analyst, data architecture, data engineering, statistician, a database administrator, and the business analyst. So when you talk about the key skills for the data scientist includes the strong command of a Python, R, and SQL, understanding of a machine language and AI concepts, proficiency in statistical analysis, quantitative analysis, and the predictive modeling, ability to visualize and report the data effectively. And the last one, the excellent communication and the presentation skills. So this is about the general information about the data science. So when you talk about the data science, the topics which I'm going to discuss is from Unit 1 to Unit 5. The first thing we're going to discuss about the applications of the data science in various fields. The data science has informative, that is transformative and informative applications across diverse fields. Here are some key areas where the data science is making in significant impact. The first one is the application where we're going to see is the healthcare. So when you come and talk about the healthcare, so the place where we're going to apply the data science concepts are the predictive analysis. Earlier, the detection of the diseases using the patent data, patients' data, such as predicting the cancer risks or the heart diseases. And the next one, the drug discovery, accelerating drugs developments using the machine learning to analyze the molecular structure, the personalized medicines, the tailoring treatments based on the genetic informations and the patient's history. The case of healthcare, the last thing that is operational efficiency, optimizing the hospital workflows, resource allocations, and reducing the patient wait times. So these are the areas where we can able to see under the healthcare services. When you talk about the finance sector, there can be a fraud detection, which is identifying unusual patterns in transactions to detect and prevent the frauds. The algorithmic trading using data driven strategies to execute trades at optimal times. And the next one, the risk assessment. When you talk about the risk assessment, we evaluating a credit worthlessness for loans and insurance premiums using the predictive models. Then the last one, the customer segmentation, the analysis, the spending, the behavior to offer the personalized financial products. Then the next one is the retail and e-commerce. In the case of retail and e-commerce, the terms we're going to see there is that is the recommendation systems. That is the suggesting the products based on the customer's preference and their past behaviors. The next one is the inventory management. So using the demand forecasting to optimize the stock levels and reduce waste. Then the next point, that is customer sentiment analysis. In this, the analyzing the reviews and the feedbacks to improve the products and the services. In the case of dynamic pricing, the adjusting prices in real time based on demands, competitions, and the other factors. Then the next option is, that is the transportation and the logistics. In this, the route optimization, where the improving delivery routes to reduce the cost and the travel time. Then the predictive maintenance, so we can monitor the vehicles and the machineries to predict and the prevent the failure of the products. And the next one is the demand forecasting. So we're going to optimizing the fleet deployment for the public transports or ride sharing services. And last one is the left driving technology, that is self-driving technology that enables the autonomous vehicles through a real-time data analysis. So this is about the transportation and the logistics. When you come to the education field for the data science, it can be used in the form of the personalized learning, adapting content to the needs of the individual students through adaptive learning systems. Then the system, that is student performance analysis system, which identifies at the risk student and improve their outcomes. The next one is the curriculum development. It can also use to develop the curriculum based on the data to assess and refine the teaching strategies. When you come to know about the resource allocation, that is the optimizing the budgets and the staffing for the schools. And the next one is the agriculture. In the case of agriculture, so the data science can be useful in the case of a precise farming, which means using the data from the sensors and the drones to optimize the irrigation, fertilization, and the pest controls. The next option is, that is crop yield protection prediction. In the case of estimating the yields based on weather, a soil, and the historical data. Then the supply chain management. In this case, the improving logistics for perishable goods. The last one, that is livestock monitoring. So we can come to know how the stock is being maintained, whether it is available or not. It has been analyzed using this data science in the case of the agriculture, that is analyzing the animal health and the productivity of the data. Then the next one is the transportation and the logistics. In the case of transportation and the logistics, though, the first one we have, that is route optimization. So here it's going to give you the a delivery efficiency for the logistics companies. The next one, the traffic management. So we can able to predicting and reducing the congestions using the real-time traffic data. Then in autonomous vehicles, enabling the self-driving cars through the advanced data processing and the AI. Then the fleet management. So monitoring and optimizing the vehicles usage and the maintenance. So these are the points we have under the transportation and the logics. In the case of energy, so we may come to know that how the energy is going to be. We may have a question that how the energy is going to be utilized in the data science. We'll see that. So that is we going to see under the energy. First one is the demand forecasting, which is predicting the energy usage patterns of to optimize the generations and the distributions. And in the case of the smart grids, in enhancing grid reliability using the real-time systems. The next one, the renewable energy optimization. In this, the renewable energy optimization, the forecasting solar and the wind energy productions. So the equipment's monitoring, the predicting failures in power plants and the distribution systems. So these are the areas where you can able to see the data science in the case of energy area. The next one is data science is also be involved in the place of entertainment and the media. The content recommendation, that is the powering the platforms like Netflix and the Spotify, with personalized suggestions. Then the audience analytics, that is understanding the viewer's preference and optimizing the content delivery. Then the sentiment analysis, which is nothing but gauging the public reactions to movies, shows, and campaigns. Then the next one, that is a social media analysis, that is tracking the trends and the customer enhancements, that is engagements. So this is about the entertainment and the media in the case of the data science. When you come to the government and the public sector, the crime prediction, that is the using the data to allocate the police resources efficiently before any crime has been occurs. The next one, the disaster management. So we can able to predict the natural disasters, and according to that we can plan the response to the activities. The next one is the public policies analysis, that is evaluating the impacts of the policies using the real world data. When the next one is the sports, where the data science also plays a major role in the case of the sports, that is the performance analytics, monitoring the athletes' metrics to optimize the training and the performance, not only for the athletes, it can be also used in all the sports categories. The fan engagements, the next point, that is enhancing the fans' experiences through the targets, the contents, and offers. Next one is the injury protection. So, using the biomechanical and the health data to prevent the injuries. Then, this is about we have discussed about the various applications of the data science. The next topic, what we're going to discuss is that is the data, the security, and the issues. So we may know that the data security is a critical concern for individuals, businesses, and the governments, as a breaches and vulnerability can have a severe concerns. Here, the some of the key issues related to the data security. The first one is data breaches. Unauthorized access to sensitive data such as the financial informations, the personal identifications, or intellectual properties. The next one is often caused by ha- hacking or phishing attacks or insider threats can lead to identify a theft, financial losses, and reputational damages. Then the next one, that is what are the next issues we may see is that is malwares and the ransomwares. The malware, that is a software designed to harm, exploits, or otherwise to compromise the devices or the data. That is example we may see about the viruses, worms, and the spywares. When you talk about the ransomware, a type of malware that encrypts the data and demands a payment for its release. The next one is the growing threat to both the individuals and the organizations. Then the next one is insider threats. So here, the employees, the contractors, or other insiders intentionally or unintentionally exposing the sensitive data, often due to a lack of awareness, negligence, or the malicious intended. The next one, it is difficult to detect the compared to the external threat. Then the next one is the weak authentication and the authorization. In the case of weak or reused the passwords and inadequate multiple factors authentication mechanisms, unauthorized access to the systems and the data due to a poor identity verification processes. Then the next one is the phishing, that is phishing and the social engineering. Here, the attackers manipulates the individuals into divulging sensitive information or granting access to the systems. It also often delivered via emails, phone calls, or any fake websites. Increasingly sophisticated and difficult to it was detect. Okay, then the next one is the cloud security issues. So misconfigured cloud storage leads to data exposure, that is inadequate access, controls, or encryptions for data stored or processed in the cloud. Then the shared responsibility for the security between cloud service providers and the users. In the case of data integrity risk, where the unauthorized alterations to the data, either accidentally or maliciously. It also affects the reliability and accuracy of informations, which is critical in areas like healthcare and finance. The next one is Internet of Things, that is IoT vulnerability. The IoT devices often lack the robust security measures, creating entry points for the cyber attacks, and it also the potential to compromise the connected systems and the sensitive data. So the next one, that is the lack of encryptions. The failure to encrypt the sensitive data in a transit or at rest, making it easier for the attackers to intercept and exploit informations. That is, the next one, the regulatory compliances. That is, non-compliances with the data protections laws like GDPR, HIPAA, and CCPA can lead to a legal and financial penalties. The next point in this, that is ensuring the compliances requires the robust security measures and the continuous monitoring. Next one is that is distributed denial of services attacks. Here, the overwhelming systems with traffics to disrupt access and the operations. It can be diversion tactics for more targeted attacks. Then the next one is the third party and supply chain risk. The security vulnerability in third party vendors or the partners can expose an organization's data, increases the risk due to interconnected systems and the shared accesses. The next one, that is data loss and backup failures. If in case any data loss of a critical data due to the hardware failure, accidental deletion, or the insufficient backups, so compromised business continuity, and it can be a recovery will be the most failure process in this. And the next one is the advanced persistent threats, that is APTs. So prolonged and targeted attacks aimed to stealing a data or espionages are typically involves the sophisticated techniques and well-funded adversary. Then the last one, in the case of the threats and issues, that is emerging threats, the AI-powered attacks, adversary using machine learning and AI to identify the vulnerability or the launches attacks. And the next one, that is quantum computing risks. So here, the potential to break the current cryptographic algorithms, making the encryption obsolete. So, in addressing these issues requires a combination of the robust technical measures, regular training and awareness, the regulatory compliances, and proactive monitoring. The security strategies can evolve continuously to counteract new and emerging threats. Then the next topic what we're going to see is the data collection and data pre-processing in the data science. So that is in the case of data collection and the pre-processing in data science, it has a fundamental steps in any of the any of the data science projects. Here, an overview of each phases. That is, in the case of data collections, involves gathering relevant informations from the various sources from the analysis. That is, this step is crucial as the quality and the quantity of the data directly impact the model's performance. So the methods of the data collections are, the first one is the primary data collections. Here we have three different category. One is the survey and the questionnaires. So this can be achieved with the help of the direct input from the users or the participants. Then the second one is interviews. So gathering the qualitative data through the conversations. Then the third one is the sensor data. So this can be collects data using IoT devices or the sensors. Then the second one is the secondary data collections. Here, in the case of the secondary data collections, so the first one is the public data sets, that is, the data sets from the open data platforms, example, Cogale, UCI Machines Learning Repository, and etc. The next one is the web scraping. So here, the extracting data from the websites using tools or scripts. Then the last point in the case of the secondary data collection is the API, that is application program interfacing, that is the collecting the data via the public or the private applications, programming inference, that is interfaces. Then the next one, so we can also get the data that from the real-time data streamers. The data collected continuously from the source like social medias, the financial markets, or streaming devices. When you talk about the next one, the enterprises systems, here the data from the internal systems such as CRM, ERP, and other databases. So the challenges in the data collections is the volume and the variety. So here it is handling the large value of the data and the diverse data sets. That a variety of data sets is going to be handled. Then the next one is the data quality. Here, the incomplete, noisy, or outdated data has been calculated in the case of the data quality. The next one is the ethical concerns. Here, it ensuring the compliances with the data privacy laws, that is GDPR and HIPAA. Okay, then the next topic what we're going to see is that is data pre-processing under the data collection process and the data pre-processing. So far we have discussed about the data collection, and now we're going to discuss about the data pre-processing, which means once the data is collected, the pre-processing ensures it is clean, consistent, and ready for analysis. This steps involves several tasks. That is, the steps in data pre-processing is the point number one, that is data cleaning. How the cleaning process is going to be happen is the handling the missing values. So by handling the missing values, we can able to clean the data. That is, immute the missing values using mean, median, mode, or using algorithms. And the second point is they remove the records with the missing data if appropriate. So one is we can add the missing values using the mean median mode or using an algorithm, or if in case after adding any data with the missing places, if it is not giving any inappropriate meaning, and then those data has to be removed from it. That is the case of handling the missing values. Then the second point under the data cleaning is removing outliers. So which detects and address the anomalies using the statistical methods or visualizations. Then the third one is dealing with noise. So removing irrelevant or erroneous data, it's called as dealing with the noise. Then the next one is data integration. In the case of data integration, we know it is going to be talk about the collecting and combining the data together. Okay, so that is the combining data from the multiple sources into a unified data set. Then the next point under the data integration is addressing the schemas, mismatches, or data duplications. Then, after the data integration, we'll see about the data reduction. So, data reduction is nothing but we're going to do some process, that is the dimensionality reduction, which is a technique like PCA, that is principal component analysis, to reduce the number of the features. And in the case of sampling, reducing the data set's size while retaining its representativeness. And the next topic is that is data transformations. In the case of data transformation, we're going to see about the normalization, which is going to tell you about the scaling data to a specific range, that is either it could be a 0 to 1. Then the standardization, the transforming data to have a mean of 0 and a standard deviation of 1. Either it could be a 1 or it could be a 0, that we say in the class standardization. Then the log transformation, that is handling the skewed data. Then the next one, the next feature what we're going to see is that is a feature engineering. In the case of feature engineering, a feature a selection identifying the most relevant variables for analyzing and the feature creation deriving a new features from the existing one. So this is the a concept of feature engineering. In the case of the second, that is coding categorical data, so the label encoding converting the categories into numerical labels or one hot encoding, that is creating the binary columns for each category. So how it is going to be performed, the category of the pre-processing data is, so we will be using the tools like programming languages called Python under Pandas, NumPy, and ScienceKit Learns, and also the R language. The case of data integration tools, Talent, Apache, Nifi. So these are the tools which is used to go for the integration. And in the case of cleaning platform, so we'll be using OpenRefine and Trifacta. So these are all the tools can be used for the data reprocessing. And the next one, why the data preprocessing matters. So improves the accuracy and the efficiency of the machine learning model, ensures the data consistency for the meaningful analysis, and addresses the biases and inaccuracies in the raw data. So the next topic what we're going to see is that is the data integration and the transformation in the data science. That is, so in the case of data integration, so the last topic we have discussed about the data collection and the pre-processing the data. With the continuation, we'll be seeing about the integration and the transformation of data into the in the field of the data science. So the data integration and the transformations are the essential processes in the data science, particularly when dealing with the diverse data sources and the formats. They aim to unify, clean, and restructure the data to prepare it for analysis. Then we'll see about in detail how the data integration and the transformation is going to be implemented. In the case of data integration, it says that the data integration involves combining the data from the multiple sources into a unified data sets, which enabling comprehensive analysis and insights. Then the steps in data integrations are, so the first step will be identifying the data, that is identifying the relevant data source, examples, the database, application program interfaces, files, and the web sources. The second point under the data identification is ensuring the sources aligns with the project objective. In the case of data extraction, here the first point, the retrieves the data using tools SQL, API, or the web scrapers. And by handling the different formats, that is structured or semi-structured or unstructured patterns is being handled in the case of data extractions. Then the third one is the schema matching. Here, the aligned data fields from the different sources, like example, customer's ID in one source and CUST ID in another source. So this is also be the same data, but it can be referred with a different name. So it is going to be identified with the help of the schema matching. And the next point, that is the data cleaning. How the data cleaning is going to be happen is, we already know that we have already discussed that by replacing the missing value by using algorithms, any other mean, median, mode methods. Okay, so addressing the inconsistency, the duplicates, and the missing values, it can be removed, and ensuring the data accuracy and the reliability. By doing this process, we can able to clean the data. Then the data merging. In the case of data merging, combining the data using techniques like joins, that is inner joins, outer join, left join, and right joins, and the unions. In the case of data consolidation, here stores the unified data set in the data warehouses like Lake or centralized databases. Then we'll see about the challenges in the case of the data integration. That is, the case of heterogenetic data, The different data format structures or the naming conversion will be the one of the challenging tasks in the case of data integration. And likewise, the next point, that is data quality. In the case of data quality, the inconsistent or inaccurate data across the sources. This is also the one of the challenges in the case of the integration. Then the scalability, integrating the large volume of data will be the more challenging process in the case of the scalability. Then, when you are talking about the real-time integration, the synchronizing the data from live stream systems, which is also leads to another challenge process in the case of data integration. And what are the tools can be used in the case of data integration is that is ETL tools, that is a Talent, Informatic, Apache, Nephi, Altrexy. So these are the tools can be used for the data integration in the case of data science. And in the case of data warehousing, so Snowflake, Amazon Redshift, Google BigQueries. This can be used in the case of the warehouse type of data. And the programming libraries can be in Python, that is Panda and PyODBC, and in the case of the R languages. Then the next topic, that is the continuity of the data integration, we'll see about the data transformations. See how the data is going to be transformed is that is it involves converting the data into a suitable formats or the structures for analysis. It ensures compatibility with machine learning algorithms are the visualization tools. So we'll see about the types of data transformations. That is data cleaning, removing noise outliers and relevant data, filling or inputting the missing values. The case of data formatting, standardizing the formats, that is date format, current currency units, everything has been the go within a standardized format, and converting the data type, that is the relevant type has to be used. Either it could be, if it is in a string, it could be used as a string, or if it is an integer, you need to convert the string into an integer. So this could be under the converting the data types and standardizing format in the data formatting. Then the data normalization, that is the rescaling of data to a specific range. It could be a 0 to 1, and reducing the impact of the large variance between the values. So then the next point, that is the data standardization. In the case of data standardization, the transforming data to have a mean of 0 and a standard deviation of 1. The common in algorithms, the sensitive of the scaling, that is SVM and KNN. So these are the methods can be used in the case of the data standardization. So the standardization part, with this continuity, we'll see about how the feature engineering is going to be happening in the case of data transformation. So creating the new features from the existing data, example, extracting year from a date, and aggregating the data, example, sum as well as the average for higher level insights. Then the encoding categorical data, in the case of encoding categorical data, converting categorical variables into the numerical values using methods the label encoding methods. The case of one-hot encoding, the binary columns for each category, and the case of label encoding, assigning a unique numeric values to the category. In the case of aggregation, combining data at a higher granularity, example, monthly sales for the daily records. Then the next one is dimensionality reduction, reducing the number of variables while retaining essential informations using a techniques like PCA, that is principal component analysis methods. And the importance of the data transformations are to enhance the data compatibility with analysis tools and the algorithms. And the next point, that is it can reduce the noise and improves the model accuracy. And the simplified data visualization and interpretations is being involved in the case of the data transformation. The tools for the data transformations are the Python or R libraries, which includes Pandas, NumPy, DPLYR. Then the case of ETL platforms, that is the talented Apache Spark has been used in the case of the data transformation. And in the case of cloud services, AWS Glue, Google Cloud Data Flows has been the case of the Google Cloud services. So, what are the best practices can be used in the case of the data transformation here is understand the data, document transformations, interactive approaches, and it can be under the category of automated. When you talk about understand the data, assess the quality and the structure of the raw data. So that is the main thing we should talk about the best practice, that is understand the data. Then, so the data transformations, that is the maintaining a clear record of all the changes made to the data. And the interactive approach, so continuously refine integration and the transformation processes. In the case of automate, use scripts or tools to automate repetitive tasks. The last point, so we'll discuss about the conclusion of the data integration ensures a comprehensive, ununified data sets, while data transformation prepares the data from for a meaningful analysis. Together, they form a crucial foundations for the successful data science projects. Then the next topic, that is how the data science is going to explorate the data analytics, that is EDA. EDA is nothing but explorative data analytics. In this, it is a critical steps in the data science workflow. It involves analyzing the data sets to summarize their main characteristics, often with the aid of visualizing techniques. Then the EDA, that is an exploratory data analytics, helps uncover patterns, spots anomalies, test hypotheses, and validate assumptions before building the predictive methods and also the models. The objectives of that is explorative data analysis is understand the data structure, that is to identify the variables, data types, and the relationship between the features. The next one is the detect outliers and anomalies. Here it finds the unusual data points that may affect the model performance. In the case of assess data quality, so it identify the missing, inconsistent, or the erroneous data. Then the discovery patterns and the trends, uncover insights and the relationships between the variables. The guide feature selection here, which determines the features are relevant for the modeling. Then the formulated hypothesis here, it develops the potential questions or the directions for a deeper analysis. Then we'll see about the steps in the EDA. So the steps is, that is the first one we're going to see about the data summary. That is the descriptive statistics, which means it use measures like mean, median, mode, variance, and the standard deviations for the statistical descriptiveness. And finally, it summarizes the categorical variables with the frequency counts. In the case of dimensionality, checks the row of now number of rows, that is samples, and the columns features. The second point under that is we'll see about the data visualization. Here, the data visualization explores the individual features, tools. What are the tools we're going to use here is histogram is being used and the box plots is being used. In the case of histogram, it shows the distribution of the numerical variables. In the next one, that is box plots, which highlights the median, quartiles, and outliers. And the next thing we're going to see, that is third point, that is bivariant analysis. Okay, what this bivariant analysis is under the data visualization, explore a relationship between the two variables. Bivariant, which deals about the two variables, and the tools which is going to be used for the plotting process is the scatter plots, shows the relationship between the two numerical variables, and heat maps visualize the correlations among the variables, and the bar charts compare categorical and the numerical data. Then the next one, that is multivariant analysis. What the multivariant analysis is, which is going to examine the relationship involving more than two variable. So we have discussed about the bivariant where we have discussed about the two variable, but when you talk about the multivariant analysis, it is going to involve more than two variables. And in the case, what are the tools we're going to use it in the case of multivariant is one is the pair plots, which is going to tell you about the visualized pairs-wise relationship, and the next one is the parallel coordinates. Here, the parallel coordinates talk about compare multiple variables. Then the next one, identifying missing and the outlier data. So the missing data is going to be identified. Use the visualizations like heat maps or missingness plots, and also by address the missing values through imputations or removals. In the case of outliers, they use box plots or the scatter plots to detect and normalize, and also which decides whether to transform or cap or exclude them. The relationship, the feature of the relationship is going to talk about the correlation analysis. Use the correlation matrices to identify the relationships between the variables, and which also helps in the feature selections and the dimensionality reductions. Then the next one is causation and the correlations. The correlations does not implies causation, that is exploratory data analysis helps form hypothesis but does not confirm them. Then, the case of feature engineering, it uses insights to create the new features like combining the variables, transforming the features for the better analysis, like example with the log transformations. And the tools and the libraries for the EDA is this, that is, we have already discussed the same tools. See, the programming tools in the case of Python, the libraries pandas, NumPy, Matplotlib, Seaborn, Plotty, and then scikit-learn. These are the libraries which can be used in the case of the data exploration part. And R language is also used. The libraries are ggplots2 and dplyr and tidyr and the data.table, so which are the tools in the case of the programming tools. And when you are talking about the interacting tools, so the Jupyter Notebook and RStudio has been used. And the case of visualization platform, the Tableau and the Power BI has been used in the case of the interactive tools. And the automated category of tools, the Python libraries like the Pandas, profiling, and the species. And the auto EDA tools such as the data prep or the detail, which has been used for in the case of the tools and the library. So, what are the best practices we can say in the case of exploratory data analysis? Is first one, we can ask questions, frame your EDA to address the specific objectives or an hypothesis, and then you can iterate with the EDS is not linear, revisit steps as needed based on the findings. The document findings, maintain a record of insights, visualizations, and the statistical summaries. Then the next one is use domain knowledge, that is, collaborate with domain experts to intercept results efficiently. Then the outcomes of the EDA is insights into the data distributions, the relationships, and the quality. Informed decisions are the features, a selecting and the pre-processing. Then, a clear understanding of the data guiding the next steps in the data science pipeline. The EDA serves as a bridge between the raw data and the actionable insights, enabling the effective model building and the analysis. Then the next topic we're going to see, that is module development. That is, we see about how the model is going to be developed. Here, the model development is the core phase in the data science lifecycle. It involves designing, building, testing, and fine-tuning machine language learning or the statistical models to derive the predictions, classifications, or insights from the data. The key steps in the data model methoding is first one, we can define the objective. How we can define the objective is by a clearly state the problem to be solved. Example, prediction, classification, clustering, or the optimization. But then, by identifying these target variables, may be independent or the dependent variable. Then the next point, that is the data preparation. So we can prepare the data by the feature selection, feature engineering, data splitting, scaling, and the normalization. In the case of feature selection, choose the most relevant feature for the model. The feature engineering create new features, transforms the variables, or encode the categorical data. The data splittings splits the data sets into training, validations, and the testing sets, etc. That is an example of 70-20-10 or 80-20 split ups. So out of 100, you may split the data into a form of a 70-20-10 or 80-20 split up concepts. Then the scaling and the normalization, the standardization or the normalize the features to improve the data model or performance for an algorithm sensitive to the scaling process. The next one, choose the model type. So by choose the model type, select the appropriate model based on the problem type. So the problem type is going to tell you about whether you may use the supervised learning or unsupervised learning or reinforcement learning. In the case of supervised learning, the regression, the linear regression, the decision trees, the random forest, is being used, etc. The case of unsupervised learning, the k-mean clustering and the DB scans hierarchical clustering is being used. And the dimensionality reduction, PCA, TSNE, and UMAP is being used for the unsupervised learning processes. Then the reinforcement learning, which uses Q learning, deep Q networks, which is also comes under the complexity, interoperability, and the data requirements of the data models. Then the third one, that is model training, train the model on the training data sets using the chosen algorithms. Then we optimize hyperparameters using methods like grids, search, or randomized searches. Then the next one, that is model evaluation. So the model is going to be evaluated. Use the validation sets to evaluate the model performance and to prevent the outfittings. So what are the common methods can be used for the validating the models is the regression, classification, and the clustering. The case of regression, mean absolute error and mean squared error and the R square has been used for the regression process under the model evaluation. And in the case of classification, the accuracy and precisions recalls F1 scores is being used. And for the clustering, Silhouette scores and Davis Baldwin index has been used for the model evaluations. Then the next one is hyperparameter tuning. The hyperparameter tuning, we optimize the model parameters to improve performance. And the case of the techniques, under what are the techniques we'll be using here, it is the technique used under the hyperparameter tuning is, that is grid search, random search, and Bayesian optimization. So that is grid search, it's going to exhausting search over specified hyperparameter values. In the case of random search, the random sampling of the hyperparameter spaces. And the Bayesian optimization, the interactively exploring a parameters space based on the past results. And the next one is the model validation. The model is going to be validated using the techniques like the cross validations to ensure robustness and generalizations. The k-fold cross validations splits data into k sets, and train or test the model k times. Access model stability across different data sets. Then the next one is the model testing. The test and the model on the separate test data sets that can not used during training or validations. Evaluates the final performance and ensures no data leakage occurred. In the case of model deployment, I deploy the trained model into a production environment for the real world use. I consider the deployment platforms such as cloud services like AWS, Azure, Google Cloud, or the local servers. Then the 10th one, that is monitoring and the maintenance, which is the last point under this. That is the monitoring the model performance over time to detect drift or changes in the data and update or retain the models are as needed. So the challenges in the case of the model development is outfitting. The model performs well on the training data but poorly on the unseen data. And the next one is the underfitting. The model is too simplistic to capture the underlying data parameters. Then the imbalanced data set, the skewed class distributions affecting the performance matrices. Then the feature correlation highly correlates features leads to multicollinearity, etc. The computational resources, training complex models requires the significant hardware to be used in the case of the model development. These are all the challenges in the case of the model development. Then the tools for the model developments are programming libraries, that is Python, Scikit Learning, TensorFlow, PyTorch, XGBoost, and CatBoost. These are the programming libraries. Then the integrated platform, that is Jupyter, the Notebook, Google Colab, and Databricks is being used. In the case of visualization tools, Matplotlib library, Seaborn, and Tableau is being used. The best practices for the model developments are we can see about the start simple, iterate, automate where possible, documents, interoperability, and the reproducibility. The case of start simple begins with the basic model and add the complexity gradually. Then the case of iterate, continuously refine a model based on the valuation results. Then the automated where the possible, use tools for hyperparameters tuning and model evaluations. Then the case of documents, keep a detailed note for on model configurations which results in the discussions. And in the case of interpretability, ensures the model's predictions are interpretable and explainable. And the reproducibility, maintain the reproducible flow works using tools like Git and ML flows. The outcome of the data models is trained and validated models that provides actionable insights or predictions, a frame for a continuous learning and adoption in dynamic environments. Then the last topic we're going to see, that is the prediction and the decision making in the data science. What is the decision making and the prediction in the data science is the prediction and the decision making are the pivotal goals in the data science. Prediction leverages data to forecast outcomes, while the decision making uses these insights to select the optimal actions. Both processes are integral to driving the data strategies across the industries. One is the prediction in the data science, which defines the involvement using historical data and the statistical or the machine learning to estimate the features, outcomes, or the unknown values. The steps in the predictions is first we should define the objective by identifying the target values, example the sales and the customers charm, and the determine whether it is a regression or the classifications problem. Then the preparation of the data, stock report, cleaning the data, pre-processing the data, and transform the data for the model compatibility. And based on that, the transformations, we're going to split the data into the training, validation, and the test sets. And later, we can go for select the models. Either it could be a supervised learning or unsupervised learning or reinforcement learning. In the case of supervised learning, the regression model and classification model is being used. The regression learning and bridged regression is being used in the case of regression. And the case of classification models, the logical regression, decision tree, and random tree forest has been used. And the trained model here use the historical data to learn patterns and the relationships, and uh, optimizing the hyperparameters for the better performances, and also evaluate. And the next and also about the other activities, evaluates the model. How to evaluate the model is measures the predictive accuracy using the matrices like aggressive, MAE, RMSE, and R square. The classifications accuracy, precisions, recalls, F1 scores, ROU, AUC. These are the classifications methods has been used in the case of evaluation strategies. Then deploying models. So when you deploy the model, which could be a trained model in a protective environment, or the real time or the batch predictions. The applications of the predictions are, so we can use the applications in the healthcare prediction, financial prediction, retail predictions, and also in the case of the marketing predictions. Then we'll see about the decision making in the data sciences. So in the case of decision making, which involves using insights derived from a data to choose actions that achieves the desired objectives, often under uncertainly. The types of decision making approaches are the descriptive analysis, predictive analysis, and prescriptive analysis. So in the case of descriptive, it focuses on the understanding the historical data to identify the data and the patterns which follows the trends. And an example for that is summarizing the sales data to detect the seasonal trends. And the predictive analysis, which uses the models for the forecast future outcomes. The example for this is the predictive customers choose likelihood to target the retention strategies. And the perspective analysis, it recommends the actions based on the predictive insights and the optimizing techniques. Example, suggesting price adjustments to the maximum revenue. The steps in the decision makings are frame the problem, gather the insights, evaluate the options, make the decisions, and monitor the outcomes. Okay, we'll see. While framing the problems, we should define the decision to be made and objectives. And in the case of gathering the insights, analyze the data using the EDA and the modeling, that is elaborative data analysis, no? Elaborative data analysis and the modeling has been utilized. And the case of evaluate optimization, use simulations, optimizations, or scenarios analysis to assess the alternatives. Then the example, simulate the impact of the different marketing budgets on the ROI. In the case of decisions, select the best course of an action based on the data-driven insights. Monitoring outcomes, track the results of the decisions, and refine the approach it needed. Right? This is about the decision, and the techniques and the tools for the decision makings are optimization, modeling, a simulation, decision tree, data visualization, and decision support systems has been used in the case of the techniques and the tools for the decision making. So the optimization models uses the linear programming, genetic algorithms, or the reinforcement and learning methods has been as a one of the optimization models. In the case of simulation, Monte Carlo simulations for evaluating uncertainty, the decision tree for the structured decision making, and for the data visualization, Tableau, Power BI, Matplotlib, and Seaborn has been used. In the case of decision support systems, the platforms integrating the data, models, and simulations for the decision making. Applications of the decision makings are the supply chain, optimizing the inventory level and the logistics routes, the finance, portfolio optimization, and credit approval processes. the healthcare, the resources allocations, and the treatment planning. And for the marketing, campaign strategies, channel optimization, and the pricing decisions. The challenges in the predictions and the decision makings are the best data quality, that is, the poor quality data can lead to inaccurate prediction and suboptimal decisions. Uncertainty, the predictive modeling cannot always account for unexpected events, that is, pandemics. And bias in models, the data or algorithmic bias can lead to unfair or incorrect decisions. In the case of interoperability, the complex models, that is, example in the case of deep learning, can be hard to explain to the stakeholders. The best practices being used for the decision making is ensuring the data quality, valid predictions, incorporate domain expertise, leverage automation, monitor, and the iterative. So these are all the best practices we can use it in the case of decision making of the data science. And the cross validation in the data science is going to talk about the it is a statistical techniques used to perform the generalization of the machine learning models, and this process ensures that the model performance well on unseen data, minimizing overfitting and the underfittings. So why use the cross validation is in order to check the generalization, model selection, the data utilization, reduce bias and the variations. That is, it ensures the model ability to the performance well on new or unseen data. In the case of model selection, it helps to compare and select the best algorithm for the configuration. And the case of data utilization, which is going to give you the efficiency efficiently use an available data by repeatedly training and testing the models on the different subsets. The reduced bias and the variance, the balance bias and the variance trades off in model evaluations. The types of cross validations are the holdout methods. The process it is splits the data sets into two different parts, trained set and the test sets, that is 70 is to 30 process. The positive point of the holdout methods is it is quick and simple, and the negative part of this is the model performance can may depends on the specific train set splits, and also it is inefficient for the small data sets. And the next method we can go for, that is k-fold cross validation. The process under this is it splits the data into kkk equally a sized folders and train the models on k minus 1, k minus 1, k minus 1 folds and test it onto the remaining folds and repeating the k number of times using the different folds on the test such each time. So compute the average performance across all the KKK iterations. And the case of the pros, it reduces the variance associated with the single train set splits and works well for the small data sets. The cons is computationally expensive for the large data sets or the complex models. The typical value for the KKK value, common value, is includes 5 or 10. Then the third cross validation method is stratified k-fold method. It's similar to the k-fold, but ensures each fold has a proportionally representations of the targeted classes. The pros is the ideal for imbalanced dataset. In the case of cons, slightly more complex to implement. Then the next one is the leave one out cross validation, LOOCV. That is, here we're going to do the process n minus 1 times the samples for the training and one sample for testing, where the triple N says that 3 times we're going to do the testing process with the sample data, and it's going to be repeated in n samples. How many number of values we're going to get? For now, that number of times we're going to perform the sample operations. In the case of pros, here use the maximum data for training in each iteration, and it is suitable for a small data sets. The cons, the very computationally intensive large data sets. Then the next one, leave P out cross validation. The process trains the model on n minus p, n minus p, and n minus p samples. So previously we have discussed about kkk, that is k minus 1, k minus 1, k minus 1 twice it has been used. And next one, the leave once out cross, we have discussed about n times, that is n minus 1, n minus 1, n minus 1, and now we're going to see about leave p outcross validation, that is N minus P, that is 3 times we're going to do the sample process, that is PPP samples. Repeats for all the possible combinations of the PPP samples, that is the pros, the under, that is thorough evaluation of the model. Computational infeasibility is a large data sets in the case of the cons. And the time series cross validations, the process, the data splits while preserving the time order, and no shuffling is going to be taken, and train on the past data and the test on the future data. Example, train on data from January to June and test on July. The pros, this maintains the temporal integrating, and the cons is limited applicability to non-time series data. Then the next cross-validation method is evaluation metrics. Here, the regression strategy is going to be used, that is mean absolute error and the root mean square error and R square scores has been used. Here, the classifications, accuracy, pre- precisions, recalls, and F1 scores and ROC, AUC is being used. And the next one, that is the application of the cross validations. What are the applications we're going to use in the case of cross validation is the model evaluation, feature selection, hyperparameter tuning, and algorithm comparisons. Best practices for this is choose the right method, avoid the data leakage, combine with the grids or the random searches, and along with the balanced computational cost. And the tools for the cross validations is a Python and R languages and automated tools is being used. In the case of test multiple parameters using grid search in the data science, here the grid search is an hyperparametric optimization techniques used in the data science and the machines, which involves exhaustively searching through a manually specified subset of hyperparameter for a model to determine the combination that yields the best practices, which use grid search. For example, we have why should we use the grid search as optimal model performance, which helps the best hyperparametric values for examining the accuracy, and the systematic exploration, which examines every possible combinations within the defined ranges, and the applicable across algorithms, which works with most machine learning algorithms. And what is grid search is it defines the grid search exhaustively search through a specified set of hyperparametric values, training and evaluating the models of the every combinations. The goal of this grid search is to identify the hyperparameter values that yields the best model performance on the validation data. The steps to perform the grid search is prepare the data, define the parameter grid, train and validate the models, and select the best hyperparameter. That is, the key parameters of the grid search CV is we can estimate and we can find the parameter grid, and we can go with the cross validation folds, and we can go for the scoring using the accuracy, privacy, and other scores. And in the case of the advantages, the exhaustive searches examines all the parameters, combining, ensuring, or the possibilities are missed, and customizable. User can tailor and parameter is based on the domain and knowledges. Integrations with cross validations. The limitation of the grid search is there is a computational cost. The time consumption for the large data sets are the many parameters. The course of the dimensionality is the search space grow exponentially with a number of hyperparameters, and in the case of static range requires three defined ranges which may miss optimal values outside the grid. Conclusion: the grid search is a powerful yet computational intensive technique for optimizing machine learning models. While it guarantees thorough exploration of the parameter space, its practicality define depends on the size of the grids and the available computational resources. Combining with the cross validation ensures robust evaluations and leads to a better performing models in the productions. So this is about the grid search technology. So finally, I want to thank to everyone who is listening, and we'll continue with a new other topic on the next session. Thank you. Thank you so much.